morning, good afternoon, and good evening, depending on where you are. So, what we have today is a very interesting project. It's a project that you're very likely to face if you're working in a data analysis or in data analysis or consultation within any organization, especially if they need support with people analytics. So this scenario reminds me of a certain task that I've had to do for the World Bank, where I was contacted by an HR representative asking for an analysis of a certain database of employees who have gone on exchange programs and then came back. And then we would like to know whether these employees had been churned, meaning had they left the department afterwards, where have they gone? And what were the factors that might have led to that? Is it a positive thing? Is it a negative thing? So today we'll have something similar to that, where we're gonna just come up with a scenario utilizing a raw data set, a randomized data set with 15,000 entries. So 15,000 employees. We will use that data set in order to develop a machine learning model that can actually predict for us whether or not the person will quit or has quit. And then using this model, we'll focus on another sample that is of 100 employees, and we will try to predict whether they will leave or not, depending on the features that are most important. And by features, I mean like what are the most valuable, effective variables that might have contributed to their decision to quit or their predicted decision to quit. So it's gonna be a little bit complicated in code, but as always, we will get through it together. And with that, let's move on and see what our problem context is. Here is our beautiful presentation. By the way, every project I try to use a different presentation because I think it's very important to keep that skill in check, which is PowerPoint instead of just using one and sticking with it. It's always good to be versatile and using different templates. And this particular template you can find on Slides Carnival, which is a very, very good website for PowerPoint templates. It's the selection is not very big, but at the very least, it's really professional and they look really good. So let's start with our scenario today. We have a problem statement that we might have shed some light on before. We have a situation where stakeholders had the sense that the churning rates are high, employees are leaving, and they realize, oh, okay, so we might have a retention problem. So they come to you, they're data analysts, and they ask you, can you explain this phenomenon a little bit? Can you shed some light? Can you tell us why? We say, okay, let's do it. And then we take a look at the database, and this is what we're gonna do together, is we're gonna build a database of both the current employees and or the ones all employees that HR has on record, which is, as I said, 15,000 entries, and then new employees, which is what we are doing this project on. We're calling it the pilot, which are 100 employees. We would like to predict whether or not they will be quitting the company and on what basis. And on the old or current employees data set, we will build a machine learning model to predict if new employees will leave and what are the factors that contribute most to that. And our deliverable will be a simple dashboard that can actually deliver this or translate these information to stakeholders in a way that is digestible. So let's translate our scenario into actually analysis questions that we are seeking to address. And those are, what is causing employees to leave? Who is predicted to leave? Are employees satisfied with their careers? And which departments have the highest churn rates? So, what does our success look like? And we have to have some criteria of what a successful project would look like. So, a successful project for us would have an accurate prediction model, and failure would be having an inaccurate prediction model. And which trends are the ones that are important? Which ones are we going to focus on? They are the features that are causing the churn. And also which actions affect the trend. So in other words, we will give them our recommendations on how they can deal with this, with these issues. So through the project, we'll be building the database in BigQuery. We'll be connecting BigQuery to Colab, and then we will build a model and then build a dashboard. So this is the machine learning plan. We will use a number of entries for the 15 for the. So again, I think before we dive into how it was done, I would like to show you the results in a very from the top sense. If you were the stakeholders, what would you hear? You would hear that we developed the model and we highlighted employees who may be at risk of leaving the company out of the 100 pilot employees or the pilot new employees. And we have found that the explanatory features in order of importance is that the satisfaction level of employees, which is, well, obvious, because if the employee is satisfied, they would not leave the company. And the number of projects that this employee is working on, so the higher the number, the less likely they are to leave. And the more years they spend at the company, the less likely they are to leave. And that the average time at work should be moderated, not too little, not too much, just moderate in order to retain them. And that higher evaluation had some effect, although not a major one. And surprisingly, like work accidents and other factors, even the salary level had limited to no effect. So what we're trying to say is, if we're trying to connect the dots, it's not particularly the salary level, it's not particularly the department, it is rather the satisfaction level of employees working in that particular department that has had the major effect. This shows our dashboard, the design that we'll come out to. I think I will, excuse me, just take you quickly to the link to see the design, and then we will switch back to the start and go build a database, then code the model, and see how we link it to LookerStudio. So this is our dashboard on LookerStudio. Of course, we have our title here. We start off by explaining what this is. We use the machine learning model to highlight employees at risk and to understand the turnover causes that might actually enable HR and management to identify which practices, the distribution of workload, and the career development opportunities that are appropriate to resolve their retention or churning issues. we have made a simple filter of just departments over here so that we can take a look at each department individually. We are also looking at the features, as we have said, what actually is driving churn. And as we have understood together, these are similar to the conclusions we had in our presentation. Is basically the satisfaction level is the leading factor, and then we have these three factors, and then finally, last evaluation are the most significant features affecting the churning rate, and then the others are a little bit more limited. And also, we want to understand where the particular churning is occurring. So we have a graph over here. It's organized basically or sorted by the churn rate for each. So out of 10 employees, management particularly has 2 employees leaving. Sales out of 11, they have 2. Then technical, and so on and so forth, while these are relatively safe. So out of 100 entries, we are predicting that 9 of the staff will leave. On what basis then? Exactly these features. How do we turn to these results? That's what our next step. And let's then switch to, I think we'll be using BigQuery, yeah? Okay, so we'll use BigQuery to import the data and then connect it to Colab, and from there develop our model. Okay, so first off, I apologize if there's a change in my voice. I just switched microphones. Hopefully this is better. So now we are looking at BigQuery, Google BigQuery, and we will attempt to create a data set and just attract the tables that we will be working on. We'll read them via BigQuery before we transfer them into Colab. The key here is we do not necessarily have to do this. We could have just gone to Colab and read the files, but it's always good to be able to understand how you can connect these different platforms if you're working with an organization that uses them. So earlier we were using different Microsoft cloud-based systems or cloud-based programs. Now we're using Google. Okay, so for instance, here is my new project. My project is XYZ, this one, and then I will here create a data set. Of course, I've already done this. You can call this whichever you want. I had called it employee churn already, US region, and just create the data set. Go through the works as usual. Once you have this data set with the info and so on, you can click on it and say create table. What we want to create the table from is we are going to upload the file that we need. So we have here the HR data. These are the current and old employees. We're going to open that first. Again, go through the movements, and if it asks you for the schema, you turn that on because the particular file is not that difficult to read. We don't need partitioning, we don't need clustering. Just move on and create the table, and then do the exact same for TBL new employees. And then we'll be moving to Colab and seeing how we can connect the two of them and pull our databases from BigQuery to Colab. Okay, so here is Google BigQuery, where we're set to first attract or read the databases that we will be using before connecting them to Colab. To tell you the truth, we do not necessarily need to go through this, but it's always good to know how to do this end to end, meaning using the Google Cloud Suite, for instance, or the Microsoft Cloud Suite, because based on which organization you're going to be working for, they are going to have some systems in place that are working around these programs or these suite of programs. So how do we create a data set in this project? We can click on the project name here and then say create data set, or the project ID here, and then create a data set. I've already created mine. I called it employee churn, multi-region, yes, and then create data set. Just go through the works, not complicated. And once it's created and you see it over here, you can click on the three dots and then create a table. And you would like to, if you've downloaded the raw data, you can here click upload and then select the file. We can browse to the location. We have two data sets that we can use. The one is the raw data of the old and current employees, and the new one is of the pilot, the 100 employees that we have, that we are gonna predict their churn ratios. Okay, so once we've pulled these two tables, let's take a look at how we can transfer them or connect them to Colab. Okay, so let's get to the saucy part over here, which is, connecting to BigQuery and creating a machine learning model. So this is basically a Python environment. The first thing we're going to do is we are going to prepare the environment to use BigQuery. So we import the BigQuery from Google Cloud. We import the authentication function out of Google Colab. And then we authenticate our user over here. You'll be prompted basically to authenticate yourself. Easy enough. And we will also be initializing the client itself. So we're going to identify or define the project ID, which we should have here. Yeah, this is our project ID basically. So you just grab it from there and put it within quotations here. And then we initialize the BigQuery client with the project being the project ID that we have identified. And then we're going to start importing the two data sets. The first thing is we're going to reference the data set, which is employee churn, with the project being the project ID that we have already identified. And our data set would be then get underscore data set from the data set reference that we have already done here. And to narrow it down further, we go and reference our table, which is tbl underscore hr underscore data. And then we grab our table using the client.get underscore table function, so we can actually have the table itself. And then we double check on the table schema. Let's see here. That means if you have something like this, means that reading of these databases is correct. So one thing to sort of emphasize is this could have been done in fewer lines, but I think it's much, much better to have it like dominoes, where you can kind of logically know what's to come. So you reference the database, the data set itself, and then you get the data set. You reference the table within the data set, and then you get the table itself. And then, you have your table. And this was for the table of HR data. This is the data that is for current and old employees. So we need to also create a new table for our pilot, which is basically 100 entries of new employees. So the only step we're going to have to repeat is to identify the new table reference, which is new employees, and then the new table, ask it to get the new table reference from BigQuery, and put it into a new table. And if we see the schema and it looks like this, then we are in the clear. So before starting this next segment, I would just like to emphasize that this, I can sort of feel that it's not for absolute beginners in Python. And as such, I will leave two links below to two different channels that have been awesome and a great resource for me and a lot of other people to get into analysis and really understand the fundamentals. This particular video is geared towards um, doing the machine learning part and the dashboard. So that's why we'll not be focusing as much on the pre-processing of data. Okay. Okay, so now we will just import pandas. We will do that call the first data frame, df. We're going to import the table itself, and then we will look at the results of the head and see if it fits. It looks good. So far, so good. We have employee ID here, which I am not sure would be, we'll have to exclude it at a certain point. And then we will create also the if2, which is the pilot part using the new table. And then in order to build our machine learning model, we're going to install Pycaret. So use exclamation mark pip install Pycaret. It will load through a lot. And then, as soon as it's finished, you can actually get to code into the model and start training it. So we picked PyCaret and we use the classification library because it is good at a whole lot of things, but mostly it's a low code machine learning library. So we do not have to code so much as we kind of let it do the job. That's the first thing. The second is it's very good at predicting whether the value is 0 or 1. So basically, it is good at identifying whether one value will be 1 or the other, and not as much as identifying the values themselves, as we will see going forward. So let's take a look at the DF. We want to see what we're dealing with here. We have 15,000 entries, 15,004. Which is fine. We have our columns here. What we want to do in the next step is use the setup function from the classification library in order to find what our target is. So our target is to identify or predict quitting the company. The session ID can be anything you would like, it's just to reference it. What we want to ignore, as we had highlighted before, is the employee ID column. This is not needed. It does not really give any insights. It's just a number. So if we take it into account, then we are basically ruining the results. And the categorical features will be the salary and departments, because salary is classified either into low, medium, or high, and the departments, we have a certain set of categories for department as well. And we process this already. We'll look at the results here. If you have something like this, it means, well, voila, it has worked. The target type is binary. This sounds good. And for the testing, the set shape is 4,500. So the training is 10,000 and the testing is 4,502. That's all good and well. So now The good thing about PyCaret, it gives you a chance to compare the different models that you can actually use in order to set your predictions. So using the compare models function, it will give you a whole lot of different models that it can use in order to train your data or predict your data, and different indicators of which one is basically best for you. So the higher the values, basically, the better the particular model is for you. And then finally, it gives you kind of an insight into which one it thinks is best. So for us, it thinks that the random forest classifier is the best one. It has high accuracy. The area under the curve is relatively high, not a big difference. Its recall value is also, compared to the top, is not that far apart. High precision, the highest F1, the highest kappa, and the highest MCC. And for TT, we're not super concerned because it's a small database. 15,000 is nothing. So we're not super concerned about the resources. I think because I have it here in dark mode, so this is like not showing automatically. Anyway, so for your cheat sheet, we have agreed together that the parameter we'll be using is accuracy. So accuracy is front and center for us. And what does provide us with the highest accuracy is the random forest classifier. So I have here a cheat sheet I keep with me whenever I'm doing machine learning in order to sort of keep in mind which one to target when I'm choosing a model. So accuracy is the proportion of correctly classified instances of total instances. So they focus on whether you have actually correctly classified an instance or not. But there is a risk of false positives if you rely solely on it. The area under curve is a very good indicator of the ability of the model itself to rank positive instances higher than negative ones, like it relates to performance. The recall ability is its ability to identify the true positives, so meaning it is important to minimize the false negatives, which is always something precious in choosing the models. And then we have the precision, which minimizes the false positives that we have. And the F1 is simply the mean of the precision and the recall. It's a balance between the two. The kappa is the measure agreement of predicted and actual classes. It also implies better performance. And the MCC is the measure of classification quality. It is sort of a balance between true and false positives and negatives. And this works even when classes are imbalanced. And TT is basically how long the model took to train. And of course, less time implies less resources. But as we said, our database is small. We do not need to worry about it. So we'll go with the random forest classifier as having the highest accuracy, the highest precision, F1, kappa, and MCC. The next step is creating our model. And we, as you have seen, we've chosen the RF, the random forest classifier. Using the create model function, we take a look at the folds. So it went over the data 10 folds and then extracted with it the mean of these rotations and the STD, the standard deviation. Now, what we're targeting usually is high means and low standard deviations. That implies we have a relatively good model on our hands. And then we identify the final DF based on the predicted model of the RF model that we have identified here. And we take a look and we see that the accuracy 99, 0.99, 0.99, these are very good results, implying we are really going into the right direction. And if we want to take a look at the df.head, We will find the columns, of course, as is, and the entries, or well, a number of the entries. And we will also find two columns here, which are the prediction label and the prediction score. So the prediction label is 1 in this particular instance. It's 1, and the person did quit the company. So it's basically the prediction score is how it rates its chances of being correct of this particular prediction. So the prediction label 0 means that they have not quit the company, 1 means they have or they will, and the prediction score is how confident they are about this piece of information. If we look at the info, as we have said, they used 4,502 entries in order to train themselves, train the model, as we have mentioned earlier. And in order to implement this prediction model onto the new or the pilot entries, we will use new underscore predictions. We'll create a data frame, basically, based on the predicted model, which we will be using our F model, the model that we have developed, and the data will be the DF2. And then we maintain high accuracy, which is a good thing. So in order to create our model, so here we have our results of the pilot. We have 100 entries. And how can we read this? We can read this as the employee ID number of 15014 here has an 87% chance to remain at the company, and 15015 has 57% chance of leaving the company. So we get what we really want, which is the prediction labels and prediction scores. Now, what we are going to do is we're going to write back to BigQuery in order to convey our results. We will make a new table called pilot underscore predictions here, and using the function of 2gbq to Google BigQuery, basically we'll write to them and tell them, create for me this table. And if it exists, replace it. And that table I want is the new underscore predictions table. It will take its time, not too long. And we will have our table here. Yes, this is the one that we are aiming for. And one very nice feature as well is that you can use the function of plot model to plot your RF model, and you can plot your features over here so that you can actually see the feature importance plot. So which particular feature or variable played the biggest part in influencing the model or the prediction of the model. As we had conveyed in the dashboard, it's the satisfaction level, number per project, the time spent at the company, the monthly hours, and the last evaluation. All the rest have moderate or to low effects. Let's also create a feature table. And so basically what we're trying to do is create a data frame out of the feature names here and the importances, which are the corresponding array, and then we will put them together, or as we like to say, zip them together into a feature table over here, into a data frame called feature table, and the columns will be the feature and its importance. And then again, we write back to Google BigQuery saying, create this table for me at the project ID that we had already identified. And if it exists, then replace it. And indeed, we have our feature table here, features and importance. So this is how we trained and tested and then applied our machine learning model via coding into uh, Python using Copilot. And it's basically end to end so far from BigQuery to Copilot. And moving on, we'll be looking at LookerStudio and how we created our dashboard. So now we move on to LookerStudio. And we are faced with a template gallery. I've already created the dashboard, but I want you to feel free to mess about with these templates. I feel like Looker Studio is just a bit clunky for my taste. I do like Power BI a little bit more, and obviously Tableau is the easiest and most logical user interface, but whatever the particular company you're working at, whatever they work with, you work with, and there we have it. That's the curse of being a data analyst. Okay, so first and foremost is how did we add the data to this dashboard? We can click on the add data here, and then guess what pops up? As we said, we're trying to import from BigQuery. So we just click on BigQuery. This hierarchy should be somewhat familiar for you. I go to the employee churn dataset and then look at my tables. The one that we have imported is pilot predictions. I already added this, but if you have not, then add it. And then also the feature table, following the same steps, click on it and add. So let's talk about our decisions for the distribution of our information or of our predicted information and KPIs on this particular page. First is you want to have a clarifying and strong title. So we have the predicted churn rates using a machine learning model for the pilot program. This already gives our HR a good idea of what this deliverable is. And we will say that our employees at risk pilot program, what we have done is we developed the model that we can highlight employees who might be at risk of leaving the company. Excuse me, let me just fix this. Yep. Using this model, we can try to highlight the employees who are at risk and, of course, understanding the turnover causes that may enable you to address the issues that they are facing. Good and well. And now, using our model, we have a particular predicted churn rate. So what we did is we grabbed the churn rates. There is no churn rate. So churn rates is basically we can have our churn rates using a calculated field. This is easier than retyping it. Yeah, so basically what the churn rate is the sum of prediction label. So it's either 0 or 1, right? So if you have 9 ones who are predicted to be leaving, then you have 9 individuals divided by the count of the prediction label. Not distinct count, of course, because that would be just dividing by 2, 0 or 1, but the count of the prediction labels, which would be 100. So we would have here 9 divided by 100, which would give us 9%. All right, and then moving on, we put another KPI, which is the satisfaction level, as one of the highest affecting KPIs or indicators or predictors for leaving the company. Number of projects, total years spent, and the average last evaluation. And I refrained from adding the average monthly hours because they um, kind of repetitive. It would be a bit repetitive to the number of projects. because having a high number of projects implies spending too much time at the company. Having an average number of projects would imply having an average time spent at the company, and so on. So, what is our second question? It was, what is driving the churn? What are the trends or the features or the main concerns to address? So, they have the satisfaction level, the number of projects, the time spent at the company, the average monthly hours and last evaluation, work accidents, and others. We simply use the feature table for that. And our metric is the importance, and sorting the importance descendingly, you get this shape. One thing to note is in style here, you should make the rows into 7 because otherwise they would be too distracting. We have a lot of different categories, but the highest ones are in these 7, and then you can just group the others instead. And here we have a bit of an explanation of what is actually driving the churn. And finally, we get to this graph where we have the departments and the employees at risk of leaving the company or predicted number of leaving staff. We have it also here as a simple visual. Yeah, we have it here as a simple visual so that they can see. I don't think there's anything particularly tricky about this. You just get the dimensions, toss the departments in. The breakdown should be with the label category. And the metric is, yeah, so we create the label category using a case one, which is an if conditional, basically, for SQL particularly. We'll say case one, prediction label is 1, then at risk, else it's classified as not at risk. And we end on that. So this calculated, or this dimension, using this dimension, we can break the data or the count of employees into these two categories, not a risk or at risk. And then the metric is the record count, obviously, so the number of employees. And the sort, I chose to have it by churn rates descendingly. Others might choose to take it by departments, ascending, for instance, to have it like by alphabet. But I thought that the best way to represent it was to kind of show which departments have the highest churn rates already. Yes, exactly like this. And with that, you have a very easy way of, or a very easy dashboard that you can use to convey your results to the stakeholders. Once again, what we did was develop a machine learning program using 15,000 entries, 10,000 to train, and 4,000 to test. And then we moved on to applying that model to our pilot program, which is 100 entries to predict who would be leaving. There's 9% at risk at the moment based on our model. And these are the main drivers of it, or the things that the company would need to address. And these are the departments that are most likely to churn if we kind of separate by the satisfaction level, number of projects, total years, and average last evaluation. I think we would find that they are a little bit lower than what we think. Of course, the satisfaction level is 10%. Obviously, these people are at risk, majorly by the satisfaction level. Total years is not that high compared to the average. It's 4 or 3.79, I believe. So now it's 2. The last evaluation was relatively high. However, as we said, it does not carry as much weight as satisfaction level, which seems to carry 3 times the more importance than the last evaluation. as a determining feature or as a feature that impacts our model. Um, with that, I hope it's clear. I'm sure that the next time will be even better. Next, I intend to make a similar model for a financial corporation, for financial people who are taking on loans and whether the loans get approved and what factors are kind of effective on that. So I'll make it better. We'll go through the code a little bit more coordinated, and we will definitely have a fun time. As always, I hope you have found it interesting. I hope you've learned something. I hope you can teach me something. If you enjoyed this video, please do like and subscribe. Next times, we'll have a bit more upgrades in the video, upgrades in the editing, and so on. I'm really starting to get into this. We'll also be using some a data set of financial, as we had highlighted, financial loan approvals and different determinants. We'll see if we can have also features and their importance of getting accepted or rejected for a certain loan, depending, of course, on a variety of things, different factors, educations, income, um, a lot of different variables. Either way, you are welcome to find, of course, this presentation more on my YouTube channel. Thank you very much for watching my video. Please feel free to view some of my other work and come on to LinkedIn, get to know me, send me something. I'm always happy to connect. And let's connect over data. And as always, happy analyzing.